This tiny piece of plastic and silicon costs less than 5 cents, but it is easily one of the most important components in the history of modern engineering. If you try to power a high-torque motor, a beefy solenoid, or a massive LED strip directly from your Arduino or ESP32 pins, you will instantly fry your microcontroller's delicate internal silicon. But drop in the legendary 2N2222 NPN transistor, and you unlock a powerful electronic switch that uses a microscopic control current to drive massive loads safely. Today, we are deep diving into the 2N2222 architecture, its pinout secrets, and the exact math you need to use it perfectly every single time. Part 1. Anatomy and the EBC pinout. Let's look at the anatomy of the 2N2222. In its most common hobbyist package, the plastic TO-92, it features 3 distinct pins. Facing the flat side with the text toward you, the pins are ordered left to right: emitter, base, and collector. Because it is an NPN bipolar junction transistor, its internal architecture is like a silicon sandwich. It consists of an ultra-thin P-type semiconductor layer called the base, sandwiched between 2 N-type semiconductor layers, the collector and the emitter. On a schematic diagram, you can always spot the emitter by looking for the pin with the small arrow. For an NPN transistor, like the 2N2222, that arrow points outward. A handy memory trick is not pointing in.
Part 2. How it operates. The Electron valve. To understand how it operates, think of the 2N2222 as an electronically controlled water valve. The main heavy flow of current wants to enter through the collector and exit through the emitter, but the path is blocked. To open the path, you must inject a tiny microscopic current into the base pin. When you apply at least 0.7 volts to the base, it breaks down the internal barrier layer. Now, electrons can rush freely from the collector to the emitter. The 2N2222 operates primarily in 2 modes: amplification mode, where a variable current at the base proportionally scales a larger current at the collector, perfect for audio signals, and saturation mode, where you inject enough base current to completely open the valve, turning it into a highly efficient digital on-off switch for microcontrollers. Part 3. The critical math and limits. Before dropping a 2N2222 into a breadboard, you must respect its absolute physical limits. According to its datasheet, it can handle a maximum continuous collector current, I sub C, of 800 milliamps and a maximum voltage of about 30 to 40 volts across its terminals. To use it as a safe switch, you need to calculate its base resistor using its current gain, denoted as HFE or beta. The 2N2222 typically has an HFE value around 100 to 300. This means if you need to drive a 200 milliamp motor at the collector, you divide 200 by a gain of 100. You only need a tiny 2 milliamps at the base to turn it fully on. To limit your microcontroller's pin to that safe 2 milliamps, you must put a base resistor in line, usually a 1 k ohm or 2.2 k ohm resistor. Forget this resistor, and the base pin will draw maximum current, destroying both the transistor and your development board instantly. Part 4. Practical tips and flyback diodes. Here is a pro-level tip when using the 2N2222 with inductive loads, like motors, relays, or solenoids. When an inductive coil collapses its magnetic field, it kicks back a massive high-voltage spike backwards through the circuit.
This voltage spike can punch straight through the silicon of your 2N2222, permanently killing it. To prevent this, always place a protective flyback diode, like a 1N4007, in reverse parallel across your motor. This simple trick diverts the toxic high-voltage spike safely away from your transistor. The 2N2222 is the ultimate Swiss Army knife component for low to medium current projects. Drop a comment below if you've ever accidentally burned one out. Hit that like button and subscribe to keep mastering practical hardware engineering. See you next time.